So, hello officers, comment whether I'm audible or not. So, can anybody tell me what's the topic today? Number system. Yes. See, number system is a very crucial topic, very important topic. Fine. Actually, number system is a topic of CAT, है ना? You might be aware about the CAT exam for MBA, CAT, then CDS and SSC CGL. But in recent past and in present time also, we have been witnessing the questions of number system. So there are n number of questions of number system being asked. Fine. So we'll see some of the important verticals of number system. See, what are the important verticals of number? First of all, you can put all your doubts in the doubt window. Either me or my team will be there to assist you with all your queries. You guys are there in the WhatsApp group, I guess. है ना? Are you guys there in the doubt group? Everybody? No? Okay. So I've created a group. Fine. Only for Quant I have created, so that you can put all your questions over the 879171. So you'll be having n number of Quant questions over here, but you have to type Olive, okay, or else I will be adding you by mistake in some other irrelevant group. So make sure you are texting Olive on WhatsApp on this particular number and try to write Olive, or else I will be adding you to some other group. Fine. Here you will be posting your groups, of posting your doubts. You can solve the doubts of other persons as well, and even I will be giving you some of the questions as well. Clear? Link is not there, you have to text it, Meghna. Clear? So tell me, for which all exams you guys are preparing for, first of all. For which all exams you guys are preparing? Today itself, the cutoff of RRB clerk has come, just now in the evening only. And the cutoff of RRB clerk out of 80 in West Bengal was 77.7, 77.5. Fine. 77.5. Fine. So similarly, see, I'm not, why I'm talking about RRB, the level of education is such that each of the students are attempting the whole score. So make sure your attempts are more. Clear? In number system, there are 5 important verticals. If I'm talking about number system, so in number system, basically 5 important verticals are there. What are the important verticals? So first we'll be finding the important uses of divisibility rule. Divisibility rule. It's the most important pattern. Why it's important? Not only because of the number system, but also because of the fact that you are going to solve DI, or you are going to solve arithmetic section or quantity comparison and all. In entire arithmetic, in entire questions of quant, wherever calculation is needed, whether you are doing simplification and all, divisibility rule is must. For an example, suppose you are having a double DI or a missing DI in which one of the data is 6720. Fine. Like 6720, fine, and one more DI is there like this, है ना? First we have to find out the nature of 672. See, what is this? If I eliminate this by 4 times of 22 is 66, 223, fine, 3 to 5 to 7. So we have to find out, what about, see, we have to find out that 672 is made up of which particular prime number. Maybe it can be a multiple of 7 or multiple of 11 or multiple of 9. So multiple of divisibility rule of 7, 11, 9 is very important for your quant section also. Clear? So divisibility rule. Apart from this, the second important thing is factors. Factors. How many factors are there of a your number. Apart from factors, the third important vertical is remainder theorem. Remainder theorem. Fourth important vertical is number of trailing zeros. And the fifth important vertical is unit place. है ना? See, number system is different. RBI, SBI, POK. Okay, very good. Number system and number series, do not get confused by number series. Okay, I'm talking about number system. In RBI or in any regulatory body examination, the level of question is very important. They will be picking some very important questions for quantity comparison, or we can just say in data interpretation, or we can say arithmetic word problem also. Fine. So in number system, we'll be seeing each in every topic we'll be seeing type wise. Okay, in whether you are doing time and work and all. So in number system, these are 5 important verticals are there. Apart from this, we have more verticals also, but these are the most important verticals. So students should also always know the divisibility rule of 2, 4, 2, 4, 8, 5 and 10, 3 and 9. They know it, right? What is the divisibility rule of 2? The unit place will be 2 or a multiple of 2 or 0. What is the divisibility rule of 4? So divisibility rule of 4 says the last 2 number will be a multiple of 4. 8 says the last 3 number will be a multiple of 8. What is the divisibility rule of 3? The sum of the terms has to be a multiple of 3. What about the divisibility rule of 9? The sum of the term has to be a multiple of 9. But what about 7 and 11? Whether you are solving simplification or you are solving arithmetic section, divisibility of 7 and 11 will be needed, either in mensuration also. Clear? See. Okay. So what about the divisibility rule of 7? Let's check out the divisibility rule of 7. Fine. Suppose 6, 2, 4, 7, 8, 2. Is it a multiple of 7? Let's check this out. Is it a multiple of 7? Let's check this out. The divisibility rules of 7 says the differences between the last 3 numbers and the rest of the numbers. The rest of the number can be a single digit, double digit, triple digit or a 4 digit number. It should be either 0 or a multiple of 11. For an example, 782 minus of 624. If I subtract this, 12 minus 4 is 8, 7, 5. So this is 158. Is it a multiple of 7? No, 158 is not a multiple of 7. Hence we can say that 624, 782 is not a multiple of 7. The differences of last 3 number and the rest of the number should be either 0 or a multiple of 7. Fine. For example, if I take a calculator, for an example, let's see. If we have 1758, 1758, 512, fine. So the difference of last 3 number and the rest of the number, 1758, 512. So this is 6, 4, 2, 1. Fine. Again, take the last 3 number and the rest of the number if you want to. So 246 minus 1 is 245. Is 245 a multiple of 7? Yes, it's an exact multiple of 7. 7 times of 3 is 21 and 35. So 35 times. So this particular number is a multiple of 7. So this is what the divisibility rule of 7 says. And what about the divisibility rule of 11? 6, 0, 4, 3, 2, 1, 8, 9, 1. Is it a multiple of 11? The differences of the odd places and the even places should be either 0 or a multiple of 11. For an example, 6 plus 4 is 10, 10 plus 2 is 12, 12 plus 8 is 20, 20 plus 1 is 21. And what about the even places? 0 plus 3 is 3, 3 plus 1 is 4, 4 plus 1, 9 is 13. So what is the difference? The difference is 8. So this is not a multiple of 11. The differences of the odd places and the even places should be either 0 or a multiple of 11. So this is what the divisibility rule of 7 and 11 says. Is it clear, everyone? Comment, is it clear or not? Is it clear with everyone? Shitiz Malik, okay. Clear. Apur Mishra, very good. Okay. For an example, what about this? Tell me the answer of this particular question. What should be the answer of this question? Look at this. 7, 8, put x, 3, 9, 4, 5. This is an exact multiple of 11. So what is the value of x? The star. Okay, so the difference of odd places and even places, 7 plus x plus 9 plus 5. So 5 plus 9 is 14, 14 plus 7 is 21. So this is 21 plus of x. This is the sum of all the odd places. Now check out all the even places. So even places will be 8 plus 3 is 11, 11 plus 4 is 15. Fine. So this is the sum of all the even places. So this particular differences will be either 0 or 11 or 33, 22, 55 like this. Fine. See, this can't be 0. The difference of two number will be 0 only if both are equal. X is a single digit positive integer, so this can't be 15, right? 15 minus 15 can be 0, but this can't be 15 because x is not negative. So it means the differences has to be 11. Fine. Fine. For the divisibility rule of 11, this has to be 11. Fine. So 21 minus 15 is 6 plus of x, sorry 6 or 6 plus of x, okay, is equals to 11. So the value of x is 5. Only if you are putting the value of x as 5, you are getting an exact multiple of 11. Is it clear? This is the exact multiple of 11. 5. Who has got the answer? Shitiz Malik has got the answer. Very good, Shitiz. 5. Is it clear, everyone? So this shows the divisibility rule of 11. So this is the divisibility rule of 11. Next, the next concept is of unit place. Unit place. This can be asked in word problem, or it can be asked in fillers and all. Unit place, है ना? Number system, very important pattern, a very important vertical is unit place. Now, unit place of a number. What is the unit place? Can anybody tell me what is the unit place of 8 to the power 63? Any guesses? What has to be the unit place of 8 raised to the power 63? Comment fast. Eight raised to the power 63. 8 to the power 63. What is the unit place? Any guesses? Any guesses what can be the unit place? It can be any number, 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9, and any single digit number. How to look for this? See, for unit place, you need to understand the cyclicity. The unit place of power repeats itself after cycles, just like days. After every 7th day, you have the same day, right? Suppose today is Thursday. So what is the day after 600 days? So what we'll be doing, either you will be calculating 1, 2, 3, 4 like this, or else divide directly by 7. 7 times of 8 is 56, 40, 7 times of 5 is 35, remainder is 5. So just go for the next 5 days, you will be getting the answer. Why I have done this? Because we know that after every 7 days, the days are repeating itself. So here, for unit place, the power of cycles repeated. So there are 3 cases. First case is 0, 1, 5 and 6. Fine. So they are having a cyclicity of 1. So these are the crucial thing which is being asked in banking sector, fine, in number system. 0, 1, 5 and 6. The unit place of 0, 1, 5 and 6 is constant. For an example, any power of 0 will be having 0, any power of 1 is 1, any power of 5 will be having a unit place of 5. For an example, 5 to the power 1 is 5, 5 square is 25 means 5, 5 cube is 125, 5 to the power 4 is 625 means 5, fine. And what about the power of 6? Any power of 6 will be 6. 6 square is 36, 6 cube is 2166, fine. So if somebody asks you what is 5 to the power 84, so you'll be saying the unit place will be 5. I don't know what is 5 to the power 84. Even the scientific calculator won't be able to calculate 5 to the power 84 because 5 to the power 84 is a humongous number, right? It's a compound interest. It's compounding. Fine. 5, 25, 125 like this. Fine. What about the unit place of 216, 217386 to the power 6432? What is the unit place? See, for unit place, only the unit place is responsible. So no need of worrying about this particular number. So any power of 6 will be having a unit place of 6. Is it clear? So this is 0, 1, 5, 6. So they are maintaining a cyclicity of power 1. What about 4 and 9? 4 and 9 can be categorized into the cyclicity of power 2. Cyclicity of power 2. For an example, 4 to the power 1. 4 raised to the power 1 will be 4. 4 square is 16. 4 cube is, see, the unit place is not repeated. 64. 4 to the power 4 is 256. Now look at this. This 4, this 6 is repeating. So after every second power, the unit place of power 4 repeats itself. For an example, so we can just say any power of 4, if it's odd, the unit place will be always 4. Any power of 4, if it's odd, the unit place will always be 4. Any power of 4, if it's even, the unit place will always be 6. 4 square is 16 means 6. 4 to the power 4 is 256 means 6. Like this. Fine. And what about 9? 9 is also having the same pattern. 9 to the power 1 is 9. 9 square is 81. 1. 9 cube is 729. See, the unit place is repeating, right? Again 9 to the power 4 will be 1. So we can just say 9 to the power 1 is having a unit place of 1. 9. And 9 to the power odd, unit place is 9. And 9 raised to the power even will always have a unit place of 1. Clear? So this is the cyclicity rule of 4 and 9. And what is left out? We have left out with 2, 3, 7 and 8. See, 4 numbers over here, 2 over here, 4 over here. These are the 10 numbers. So they are maintaining the cyclicity of 4. 2 to the power 1 is 2. 2 square is 4. 2 cube is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. See, the unit place is repeated after 4th power. Similarly, 3 to the power 1 is 3. 3 square is 9. 3 cube is 27. 3 to the power 4 is 81. 3 to the power 5 is 243. So the unit place is repeated after this. Now, it's not feasible for a student, if he or she is having a lack of practice, they might forget this. Fine. So they should not be forgetting this pattern. Fine. Any number, whether this or this, they will definitely repeat after 4th power. If a number is repeating after every single power, it will definitely repeat after every 4th power. If a number is repeating after every second power, it will definitely repeat after 4th power also. So if you are forgetting anything, remember this: any single digit number will always repeats its unit place after the 4th power, whether it's 0, 1, 5, 6. 1 to the power 1 and 1 to the power 5, same thing, है ना? 4 to the power 1 and 4 to the power 5, same thing, है ना? So any number follow the cyclicity rule of 4. So we'll always follow the cyclicity rule of 4. For an example, है ना? This is a question. You have to calculate the unit place of this number. Tell me what's the unit place. Let's check who is giving the answer. See what to do. For unit place, only unit place is important. So 3 to the power 167, you have to calculate the unit place of this number. For unit place, only unit number is important. So we have power 167. Divide the power by 4, because 3 after every power of 4, every 4th power, the unit place will always repeat itself. So much of power. So first break this power into 4 fours. So 167 divided by 4, the remainder will be 3. 16, this is 7, 4 times of 1 is 4, the remainder is 3. So the remainder is important. 4 raised to the power 3 raised to the power 167 will have exactly the same unit place as 3 raised to the power remainder. I'm not saying that 3 raised to the power 167 is equals to 3 raised to the power 3. No, but the unit place can be same. Unit place is the single digit that can be same. So 3 raised to the power 3 is 27. So we can just say the unit place is 7. The unit place of this power will be 7. For an example, what I have done, see again I'm repeating it. So dividing the power by 4. I'm dividing the power by 4. Why by 4? Because we have seen the cyclicity of 4. After every fourth power, the number will repeat its unit place. So when divided by 4, the remainder is 3. Achha, what can be the remainder? The remainder will be either 0, 1, 2 or 3, isn't it? If you're dividing any number by 4, you won't be getting a remainder of 5, right? If you're dividing by 4, will you be getting a remainder of 7? No, not possible. The remainder will be less than that particular number. So the remainder will be either 0, 1, 2 or 3. If the remainder is 3, put the power 3. If the remainder is 2, put the power 2. If the remainder is 1, put the power 1. But if it's the remainder 1, put the power 4, because in the cycle it's on the fourth power. Fine. So here we are getting the remainder unit place as 7. Clear? Very good, Benelva. Very good. Fine. For an example, let me give an example. So tell me what is the unit place of 18 to the power 92, 94. What is the unit place of this? In fraction of second, we can give this answer. What is the unit place of 18 raised to the power 94? What should be the unit place? 18 raised to the power 94. What can be done? Divide the power by 4. Till 92 I will be dividing it. So the remainder will be 2. Fine. So 8 raised to the power remainder is 2. So I will be writing 2. Divide the power by 4. If you divide the power by 4, 23 times 2, so the remainder will be 2. If the remainder is 2, put the power 2. If the remainder is 1, put the power 1. If the remainder is 4, put the power 4. If the remainder is 3, put the power 3. If the remainder is 0, means put the power 4. So 8 square is 64. So we can just say the unit place will be 4. Is it clear, everyone? Comment whether it's clear or not. Is it clear? If you are calculating the unit place of a number, take the unit place, divide the power by 4, check out the cyclicity, what is remaining. After every power of 4, the unit place will be repeating itself. The remainder was 2. So put the power 2. 8 square is 64. The unit place will be 4. I hope this is clear. Is it clear? Comment, everyone. Lakshmi, Kshitiz, Apurva Mishra, Apurv Mishra, Shalar. Okay, I will, Meghna, I will decrease my speed, don't worry. Actually, RBI is a bigger exam. So that's why we will be covering most of the topic in the classroom itself, right? So I'm trying to see, it's not like that I will be only giving one concept, I will be skipping. No, I will be making the practice also. Fine. So it's quite good to be fast and practice more question rather than doing the single question. Hai na? So see, what about 387 raised to the power 63? Tell me what is the unit place of this number? What is the unit place of this number? What should be the unit place of this particular number? 387 raised to the power 63. Let's see who is calculating this. Try it out. Done. What can be done? 387 to the power 63 unit place, only 7 is responsible. 7 to the power 63. Divide the power by 4. if you're dividing 63 by 4 till 15 times, it's 60. Remainder will be 3. So the remainder is important. Either the remainder will be 0, 1, 2 or 3. If the remainder is 1, put power 1. If the remainder is 2, put power 2. If the remainder is 3, put power 3. If the remainder is 0, put power 4. Sir, now 7 to the power 63 will be having the same unit place as 7 to the power 3. 7 to the power 3 is 343. So definitely the unit place of this number will be 3. Is it clear? Meghna bacha, is it clear bacha? Comment. Sona is very good. Shetiz Malik, very good. Is it clear? Everybody, is it clear? Comment everybody. Shall I give you practice of this question? No, practice this. Tell me this. See, before coming to the question, I've given you the concept and concept. If I would have directly jumped into it, you might have missed it. So I will be giving you the thorough concept of everything. You should not be mugging it up everything. You have to always divide it by 4, Apurv. Reason being, cyclicity of 4 is there. Just like week. Week is having a cyclicity of 7. Just like nature of number, every number after every fourth power will definitely repeat its unit place. What about this? See, there are 3 number. Here 4 raised to the power 1793. Multiply by 5 raised to the power 317. Only unit place is needed into 1 raised to the power 491. See, we know that any power of 1 will always be having a unit place of 1. Any power of 5 will always have a unit place of 5. Hai na? 5 to the power 1 is 5, 5 square is 25, 5 cube is 125, 5. Hai na? And what about 4? See, for 4, check out the power. Power is odd, or else you can divide it also. But it's beautiful to see the power of 4 and 9. Power is odd. Acha, power of 4 odd means 4 to the power 1 means 4. So we can just say the unit place is 4. If suppose somebody is dividing it, divide the power by 4. How to divide the power by 4 and check out the remainder? Let's divide the last 2 numbers. If we divide 93 by 4, the remainder will be till 92, it will be eliminated. Remainder will be 1. So 4 raised to the power 1 is 4. And also we have seen that 4 odd power is 4. Hai na? We have seen this. See, 4 odd power of 4 is 4, and even power 4 wins 6. So we can guess 4. So 4 multiplied by 8, put the sign, multiply 1, that is 20. So we can just say the Uttar Pradesh or the unit place will be 0. Is it clear? So 0 will be the unit place. Comment everyone, is it clear or not? For 1, any power will be 1. For 5, any power will be 5. And what about 4? Either you divide the power by 4 and check out the remainder. Rather than that, for 4, we have an opportunity. Power of 4 will be either 4 or 6. 4 or 6. 4 or 6. 4 or 6. 4 to the power odd number. 4 to the power 1 is 4. 4 means 4. Clear? Should be 0. Yes, 0, 0, 0, 0. Very good, very good, very good. Clear na? बहुत सुंदर, खतई, खतरनाक. Now, this is recurring. Recurring numbers. How to do the concept of recurring? 0.2 bar. What is 0.2 bar? 0.2 bar is representing that the number is being repeated n number of times up to infinite terms. Fine. So number of bar represents the number of 9. So this is 2 by 9. This can be written as 3 by 9. And this can be written as 32 by 99, as there are 2 power, and as the bar is on the 2 numbers, 99. So just add the numbers. If I add this, we'll be taking LCM as 99. 9 times of 11, that is 22. 9 times of 11, that is 33, and this is 32. If you add all the number, it will be 87 divided by 99. Now you can write either this, or we can convert this as 0.87 bar, because 87 bar can be represented as 87 by 99. So answer of this particular question will be 0.87 bar. So the bar is representing the number of 9. After decimal, if we have the bar, that is representing the decimal, and before decimal if we have bar, that represents the mantissa of that particular number. Find if the number is like this, 2 bar 0.3, it means it's a mantissa, it's representing -2 plus of 0.3. That's the mantissa. If before point we have, this is mantissa. You might not have aware about this, but this is a very basic of number system. Mantissa, recurring. If after point we have bar, people generally know this pattern, but people generally don't know this mantissa. If the bar is in the front of a number before the decimal, this is representing the reoccurrence of that particular number. If it is this is represented as 32, 32, 32, 32. That's why we have written this as 0.32 bar. But if the bar is in front of the number before the decimal, that represents the mantissa of that number. What is mantissa? The negative sign. Clear? So this is, I guess this you can do this now. This you can practice now. One question I am giving, one question you should do it. Comment the answer. We'll be seeing remainder theorem today. We'll be seeing factors today. We'll be seeing unit places we have seen. Your unit places we have seen. Divisibility we have seen. We'll be seeing number of trailing zeros. So these are the 5 important verticals. Apurv Mishra has got 1. Okay. Others? Dekhe bhaiya. Let's see, brothers. Okay. This can be written as 11 by 99 plus of 22 by 99 multiplied by, we have 3 over here. So this is 99, 33 into 3. 33 into 3 is 99 by 99. So that results end up to 1. So answer of this question will be 1, which is option this. Is it clear? Is this coming for everyone? Apur, very good. Suna, very good. Chatalvi Schiller, very good. Kshitiz Malik, very good. Meghna Dhote, very good. Sorry if I'm pronouncing your name wrong, because there is no gap between your name. Now, what about this? Achha, this is an equation based on number system, a simple equation based number system question. Let's see, this is a word problem. Let's see whether you are able to solve this or not. Okay, let's see this. A man engaged a servant on the condition that he would be paying him rupees 90 and a turban after a service of 1 year. Means if you are working for 1 year, I'm promising you that I will be giving you 90 rupees and a turban. See, in the previous days, let's say some 100 years before, turban, or we can just say sandals, they were valuable, right? So people used to give 90 rupees. See, let's suppose your grandfather's grandfather, for them 1000 rupees was very heavy, and 90 rupees, 30 rupees to 10 rupees were very heavy. So the farmer was the servant was getting this. He served only for 9 months. He didn't work for the entire month, entire 12 months, and he's getting what? 65 under turban. So what is the cost of the turban? So we can just say, acha, what if I say that I'm getting 24,000 in one year? If in 1 year I'm getting 24,000, so per month I'm getting what? So per month I'm getting 2,000 rupees, isn't it? 2,000 into 12. So that is the concept I'm using over here. He's getting 90 rupees and a turban. Let's say the cost of turban is T. This is the payment of entire year, means 12 month. So the moment you are dividing this by 12, so you are calculating the payment for each month. So this is the payment for each month. He is getting 65 rupees and a turban for 9 months. So divide this by 9. So this is the payment for 1 month. By dividing it by 12 and 9, we are equating the payment of 1 month, and the payment of 1 month will be equal. Fine. So 3 times of 4, and this is 3 times of 3. So we can just say 270 plus of 3t is equals to 260 plus of 40. Take this t over there, so t is equals to 10. So the cost of turban will be 10. The cost of turban is 10. Is it clear? Turban is 10 rupees is the cost of turban. Clear? 165, my god. कहाँ लेके जा रहे हो आंसर को? 10 rupees is the cost of turban. Is it clear, everyone? I have equated the payment of each month. Acha, concept of digital sum is also very important. We'll be using it. है ना? Concept of digital sum. How many of you are aware of the concept of digital sum? Comment. Do you know the concept of digital sum? We will be using this in each and every topic and in each every data interpretation. Do you people know the concept of digital sum? Who all know? Comment yes or no. It's the most important astra or shastra, we can say. It's the most important thing a student must have to eliminate the options of DI, to eliminate the options of arithmetic. Clear? It's a very important thing, the concept of digital sum. We'll be seeing at the end of the lecture, okay? Clear? Okay. Factors. Now, how to calculate factors? Let's see. Factors. Let's, for an example, take a number 20. How many factors of 20 are there? Fine. So factors of 20, let's see. We have 1, we have 2, we have 4, we have 5, we have 10, and we have 20, isn't it? So 20 is having 6 such factors, and 20 is having 6 factors. So how to calculate a factors of a particular number? Let's say a larger, let's say 1500 or 6800. How to calculate the number of factors of a particular number? For that, you have to divide the number into the prime number form. So this can be written as 2 to the power 2 and 5 to the power 1. Say 4 into 5 is 20. First of all, you have to represent that particular number in the form of prime number. 2 is the only prime number which is even. All the prime numbers are odd. So you will be writing the number in the form of 2, 3, 5, 7, 11, 19 like this. Fine. For calculating the number of factors, that individual natures are needed along with their multiplication. That is, means there are 2 2's over here. They all are factors. 5 is also a factor. 5 multiplied by this 2 is factor. 5 multiplied by 4 is entire 4 is a factor. This complete multiple is a factor, and 1 is also a factor. So how to calculate the number of factors? For calculating the number of factors, just add 1 to the power of the number. Just add 1. So that is 3. Just add 1, that is 2. So there are 6 factors. So we can just say 6 factors of 20 is possible. What I have done? First, I have bifurcated the number into the prime number form. Then after bifurcating it into prime number form, just increase the power by 1. So 3 into 2, that is 6. For an example, let's say if a number is 2 to the power 4 multiplied by 5 to the power 7 multiplied by 7 to the power 2. So how many factors of this particular number n is there? But just increase the power 5 multiplied by increase the power 8 multiplied by 3. So that is 5 into 8 is 40 into 3 120. This particular number 2 to the power 4, 5 to the power 7 and 7 to the power 2, this particular number is having 120 factors. This is a very great number, right? It's a very large number, है ना? It will be in millions or trillions, millions or billions, है ना? This particular number, it's a multiplication, है ना? It may be in millions. So this particular number is having 120 factors. This is how you calculate the number of factors. So for an example, if we have this, find out the total number of factors of 240. So what to be done? So 240, break this number in the form of prime number. Let's say 4 times of 60, and this is 4 times of 15, and this is 3 times of 5. So this 240 can be written as 4 into 4 is 16. That means 2 raised to the power 4. है ना? 2 twos over here, 2 twos over here. So 2 raised to the power 4, 3 raised to the power 1, and 5 raised to the power 1. Now for calculating the number of factors, increase the power by 1. So 4 plus 1 will be 5, 1 plus 1 will be 2, and 1 plus 1 will be 2. So there are 20 factors of 240 is possible. Clear? So there are 20 factors of 240. 240 is having 20 factors. You need not have to write all the factors. That is not necessary. The examiner won't be asking you what are the 20 factors, write down the 20 factors. No. How many factors are there? How many even factors are there? How many odd factors of 240 are there? What are the sum of factors of 240? What are the prime factors of 240? They will be asking you this, right? So 240 will be represented in this form. So these are all prime numbers, say 2, 3, 5 and all. है ना? Then increase the power by 1. So 220 factors. Is it clear, everyone? Comment that it's crystal clear or not. Is it crystal clear? Comment in yes, it's crystal clear, or no, it's we are still having dilemma. If it is clear, then I guess that you might be taking only 10 seconds in answering this question. This is into, okay, multiplied. Find the number of factors of the product of this particular number. How many factors are possible? So you can put all your doubts in the group, है ना? I will be answering all your groups doubt. Even students are there, they will be answering. You have to answer them. There are questions as well. Option C. Shitiz Malik has got option C. Apurva Mishra is also C. Sona Zangra, if I'm not wrong, she or he is also having option C. Okay, let's see what are the number of factors. They are already in the form of prime numbers. So increase the power by 1, that is 12, multiplied by 20, multiplied by 24. So 12 into 2 is 24, 240 multiplied by 24. So square of 24 is 576. So 5760. So there are 5760 factors. Clear? बहुत बढ़िया, very good. Now all the factors will be either even or the odd. Numbers are either even or odd. Fine. So how to calculate the number of even factors or odd factor? Let's check this out. So here we have to calculate the number of even factors of 360. How many even factors of 360 are possible? Try this out. Try this out. How many even factors of 360 are there? Very good, everyone. Very good, very good, very good. Your comments are being seen. Okay. Look at this. First, break this particular number into prime number form. for a moment I'm breaking this as 4 and 90 and 2 and 45 and 5 and 9. That's it. So 360 can be written as 4 into 2 is 8, so that is 2 raised to the power 3. 9 can be presented as 3 square and 5 to the power 1. So this is 360. है ना? 8 into 9 into 5. Clear? 360. If somebody asks you how many factors are there, how many factors are there of 360, so you will be doing what? You will be increasing the power, that is 4, multiply by increase the power by 1, that is 3 and 2. So there are 24 factors which is there in the option. Fine, 24 is there in the option. Definitely it's there in the option, so that's not the answer. Why? We are not here to calculate the total number of factors. 360 is having total 24 factors. What are the factors of 360? 1, 2, 3, 4, 5, 6, 8, 10, 12. So like this we have 24 factors. But I need to discard 1, 3, 5. Why? Because they are the odd factors. I am not at all interested in the odd factors. So what can be done? What process to be made? See, the nature of even number is such, even number when multiplied by even number will give the result even, and the even number when multiplied by odd number will always give the result even. Even, it means even multiplied by even is even multiplied by odd is even, right? So what I am doing is, I am taking 2 out of the box. Why I am taking 2? Let me explain you. Why I am doing so? If I take 2 out of the box, any number or any pair of number which will come from inside, and it will be multiplied by 2 will become even in nature, isn't it? For a moment, if outside the room we have red color, so when whoever will walk outside the room, his legs will be all red in color. So even multiplied by any number which is coming from inside will be becoming even. 3 into 2, 6 even. 15 into 2, 30 even, right? So now calculate the factor. So number of factor will be increase the power, that is 3 multiplied by 3 multiplied by 2. So that is 18. So 18 factors is possible. So there is 18 factors which is even. Out of 24, 18 are even and the rest 6 factors are odd. What I have done, what kind of logic I am making? Sir, I am taking 1, 2 outside. So any number, any pair of number which is coming from inside will, when multiplied by 2, will become even. For an example, let's give you an example also. Suppose there is a number n which is 2 to the power 4, 3 to the power 2 and 7 to the power 3. So how many even factors are there? If the examiner is asking about the even factors of this, so what can be done? So what I'm saying is, I'm taking 1, 2 outside, right? So 2 to the power 3, 3 to the power 2 and 7 raised to the power 3. Fine. So how many factors from this increase the power? That is 4 multiplied by 3 multiplied by 4. So 48 factors are there. Fine. This particular number are having 48 factors which is even in nature. Is it clear? Is it clear, everyone? Comment or not? Comment whether it's clear or not. Why I'm taking 2? है ना? Clear? Acha, what if the examiner ask you how many factors of n are possible, which is exact multiple of 12, multiple of 6, let's say multiple of 6. If they are asking multiple of 6, I will be taking 2 into 3 outside. In that case, it will be 2 to the power 3, 3 to the power 1 and 7 to the power 3. Any number which is coming from inside will multiply by 6 and become a multiple of 6. So this is 4 multiply by 2 multiply by 4, 8, 32. So there are 32 factors, isn't it? So 32 factors of this particular number are possible, which is already a multiple of 6. If you need a multiple of 10, take 10 outside. In that case, 5 will be there. In here, if you want a multiple of 28, take 7 and 4 outside. If 28 is outside, any number which will come from inside, multiply by 28 and it will become a multiple of 28. So that is the logic of what I am using for the even case. Clear? Now, what about the odd factors? In any case, if you are not getting anything, you can ask me directly. There should not be a loophole in the preparation. I will be doing step watch. I won't be doing randomly. So in a particular topic, let's say percentage, I will be doing like based on election, based on income expenditure, based on price consumption. If we are doing profit and loss, we'll be doing unit place article, discount and all like this, right? So in every topic, I will be doing stepwise. I'm not running like this. No, 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 I have to clear right now only. No, it's not like this. It's preparation needs a time, right? It needs a time of at least 3 months. You know, in 3 months, you will be very strong enough. Will become very strong enough. Okay, how many odd factors are there? Okay, let's find out the odd factors. This is 420. So first break this. 4 times of 105. Fine. Okay. So we'll write this particular number 420 as 2 to the power 2, 3 to the power 1, 5 to the power 1, and 7 raised to the power 1, isn't it? Now look at over here. We have to calculate the number of odd factors. We have to calculate the number of odd factors. Sir, just now you told me, and even we know this, that even number when multiplied by even will be even, and even when multiplied by odd will always be even. So even is having a dominating effect, even, isn't it? So unless and until I am not removing this even number, I won't be getting any odd factor, because any even number when multiplied by odd number will be even only. So in case of odd factor, just check out the odd result. You'll be getting the odd factor from here. Individually they are odd factor and the combination of them are odd factor. So increase the power, same process. If you are increasing, that is what? That is 2 multiplied by 2 multiplied by 2. What logic did I made? The simple logic that even should be removed for odd factor. So 8 factors are possible which is completely even. Is it clear? Which is completely odd. Abhash Kumar Jha. Arey Jhaji, kya baat hai Jhaji. Very good. Sheller, very good. So you guys belong to which state or which city? You all are Indians, but still, which state or which city are you guys belonging? Where are you put up right now? Everyone. Bhopal, Madhya Pradesh. Okay. Delhi, Mishra ji, Delhi. Okay. Delhi. Jamshedpur, Tata Nagar. Arey wah, kya baat. I stay in Kharagpur. Very nearby Jamshedpur. You might be aware of it. It's in West Bengal. But right now I'm in Dehradun. Okay. So my family lives over there. And I live in Dehradun. I am from Dehradun. Satra, Maharashtra. Okay. Great. Good. See, outside my window now, if I see, this is the curtain of a window, and if I just remove the curtain, in the front, you see the mountains of Mussoorie glittering with lights. In the front of my window, it's totally greenish, and at the night, the mountains are glittering because it's just 27 kilometers far from my house, or 20 kilometers. And in mountains, there is no means the mountains are quite visible. It's deadly clear. So it's there. Okay. So this is odd factor. Acha, one more thing. How to calculate the number of prime factors? Even that is important. Prime factor. If prime factors are needed, you just add all these powers. That is 2 plus 1 plus 1 plus 1. So 5 factors are possible. 420 is having 5 factors. There are 2 2s. Individually they are prime numbers. 1 3, 1 5 and 1 7. So these are the prime factors. Here if they need, what is the prime factors? Prime factors. So we'll be adding this 4 plus 2 plus 3. So these are the number of prime factors. So this is how you calculate the prime factors. So write it down also. So next concept. Let's move to the next concept. Acha. After this concept, we'll change the concept of factors. This is a previous year question. Let's see whether you are able to do this or not. Whether you are able to portray your logics or not. Can anybody tell me what is the number of factors of this particular question? Let's see. Okay, sir, for calculating the number of factors, we know that you have to put the numbers in the form of prime numbers. So I'm solving this 4 to the power 11. So 4 to the power 0, 4 to the power 1, 4 square and 4 cube. I'm taking 4 to the power 11 common. You have to represent the number in the form of prime numbers. So we can write this particular number as 2 raised to the power 22, 1 plus 4, 4 square is 16 plus 64. So this is already a prime number, 2 to the power 22 multiplied by 85, isn't it? So this can be represented, this entire identity can be represented like this. So we can just say this is 2 raised to the power 22 into 5 raised to the power 1 into 17 raised to the power 1. This is n. I have not changed the number. This and this are same, and it's not like I'm changing the number. It's same. So it's the simplified version. So I have successfully written the number in the form of prime number. The moment I have done so, now I will be able to calculate the number of factors, number of even, odd, prime, and everything. So for number of factors, what we have to do is add 1 to the power, that is 23, multiplied by 2, hence we can just say 92 factors are possible. So this becomes the answer. So this is your answer, 92, which option A means Andre Russell is your answer. So A for Andre Russell will be the answer, and A for Abhash Kumar Jha has given the answer. Very good, Jha ji. बहुत बढ़िया. Tata Nagar Jamshedpur. Where Sakshi Mango Bistupur. Clear? Now, before coming to the next concept, let's see the next concept. What is the next concept? The next concept is trailing zeros. Trailing zeros. Trailing zeros means how many zeros are there at the end, at the right hand side. Fine. For an example, if I see 400 000 708 0 0, how many zeros are there? So only 2 zeros. I'm concerned about these zeros at the end. Here, how many zeros are there? So there is no zeros at the end. So in examination, if it asks about the number of zeros, so they are asking about the trailing zeros. Now, number of zeros entirely depend upon the product of 2 and 5. If 2 and 5 are not there, you won't be getting any zeros. For an example, if you have 2 into 17 into 13 into 19, you won't be getting 0 at the unit place. See, what is the unit place? 2 into 7 is 18, 8 into 3 is 24, 4 into 9 is 6. The unit place is 6, it's not 0. Because 2 is there but 5 is not there. Similarly, if we have 15 multiplied by 19 multiplied by 23, 33, you will be getting 5 at the place, you won't be getting 0. Number of zeros always depend upon the possible pairs of 2s and 5. What does this means? For an example, if we have 2 raised to the power 11 and 5 raised to the power 3, so how many zeros are possible? Only 3 zeros are possible at the end. Reason being, it's just like marriage. If there are 11 brides, see, there are 11 brides and 3 grooms. If I'm considering 5 as groom and 2 as bride, there are 11 brides and 3 grooms. So the number of marriages will be only 3. Number of zeros depend upon the possible pair of 2 and 5, and that too on the minimum power, which is minimum. It's not just only 2 or 5 only. It depends upon the 2 as well as 5, whichever is minimum. Let's say 2 to the power 19, 2 raised to the power 19 and 5 raised to the power 31. How many zeros are possible? So 19 zeros, because there are 19 brides and 31 grooms. So how many marriages are possible? So 19 marriages. If suppose 2 to the power 8 and 5 to the power 8, how many marriages are possible? So there is proper pair of 8, 8 brides and 8 grooms. 2 to the power 4 and 5 to the power 73, how many marriages are possible? Only 4 marriages are possible. Clear? This is how we calculate the number of zeros, trailing zeros. Now 1 into 2 into 3 into dot 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 up to 20. If somebody asks you how many threes are possible, how many threes are there in from 1 to 20, how many threes are there? So by Fermat's theorem or by successive division method, we can calculate this. This is the method of calculating the highest power of a particular number in a product. For an example, if I want to see what is the highest power of 3 in 20 factorial, this is exactly 20 factorial. So what I will be doing is I will be dividing 20 by 3. So 3 times of 6 is 18, till 6 it's going. Hai? We have to see the quotient. And 3 times of 2. Fine. Now it's not possible to divide. Eliminate this, leave this and add this value. So 6 plus 2, 8. So we can just say there are highest power of 3 in 20 factorial. This is exactly 20 factorial. So in 20 factorial or from product of 1 to 20, there are 8 threes. The highest power of 3 is 8. 8 threes. How 8 threes are possible? See, 1 on 3, 1 on 6. On 9 we have 2 threes. 1 on 12, 1 on 15. On 18 we have 2 threes. See, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 threes. Any number, any set of number. If I want to find any number in a particular pattern, the highest power of a number, divide that number successively. Now, same concept I will be using over here. Suppose the question asks you like this: find the number of, they will be either saying trailing zeros or simply they will be saying zeros. Find the number of trailing zeros in 200 factorial. Fine. How many zeros are there in 200 factorial? Means from 1 to 200, 1 into 2 into 3 into 4 into 5 into up to 200. If you're multiplying all the numbers, how many number of zeros will be there in the end of the result? How many trailing zeros are there? So what concept I will be using is, sir, I know that 200 factorial will be written as 1 into 2 into 3 into dot 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 up to 200. Fine. It's not possible to calculate in calculator. You won't be possible. It's not possible at all. Your scientific calculator also won't be give this. It's a humongous number, isn't it? Even if you're having scientific calculator, then also you'll be not able to calculate this. See, number of zeros depend on the pair of 2s and 5. So we have to search for the number of 2s as well as number of 5. Whichever is less, that is needed. Just like marriages. If we have 7 brides and only 2 grooms, the number of marriages will be 2. So here, number of 2s are immense. See, every second number is 2. 2, then 4, then 6, then 8. In 8 we have 3 2s. Oh. In 16 we have 4 2s. So number of 2s are more. Number of 5s are less. Every fifth number is 5, right? So let's count the number of 5. How to calculate the number of 5? Divide 200 by 5. Successively 40 times. Divide 40 by 5, that is 8 times. And from 1 to 8, let's see the number of 5, that is 1 time. 5 times of 1 is 5. Fine. Eliminate this and add all the values. So 40 plus 8 plus 1. So we can just say 49. So we can just say the highest power of 5 possible is 49. So there are 49 5s, hence 49 zeros. If we say, let me explain this again. In 200 factorial, what are the number of 5s? How many 5s are possible? If you want to check out the number of 7, divide successively by 7. If I divide this by 5, there are 49 5s. It means the power of 5 will be 49. And what about the power of 2? If we divide this by 2, 200 by 2 is 100. So 100 is over here only. The 2 will be more in number, right? So there are more number of 2s. 5s are only 49. 2s are more than 100. So definitely 49 grooms and more than 300 twos or more than 49 twos, marriages will be 49. Clear? This is how you calculate number of zeros. Tell me, let's see whether you are giving the answer properly or not. Who gives the answer? Tell me the number of zeros. Number of zeros in, let's see who is giving the first answer. Number of zeros in 320 factorial. Calculate the number of zeros in 320 factorial. Let's see who is giving the answer. Significance of trailing zeros in mathematics, sir. See, there is no direct significance, but in number system, in quantity comparison, they can give. Where quantity 1 is the number of zeros in 300 factorial. They will be giving you like this. है ना? Number, है ना? And quantity 2, they will be giving the unit place of this. So compare both the quantities. Like this. It's a part of number system. In number system, it's a very important part. It's not necessary that they will be giving number of zeros, but it's a very important verticals of number system. Number of zero, unit place, divisibility rule, remainder theorem, and unit place. These are the 5 important vertical of number system. Fine. Number of zeros in 320 factorial. Is it clear, bacha? So 320 divided by 5. 5 times of 6 is 30, 20. So 64 times. Again divide this by 5. Check out the coefficient till where it is going. 5 times of 12 is 60. Again divide this by 5. 5 times of 2 is 10. Now not possible to calculate further. Eliminate this and add all the numbers. 64 plus 12 is 76 plus 2 is 78. 78. So we can just say the highest power of 5 is 78. Hence the number of zeros will be 78 zeros. So 78 zeros at the end. Is it clear for everyone? Number of zeros in 320 factorial is 78. Is it clear? Last question. Is it clear? Comment everyone. Is it clear or not? Last question. Let's see who all are giving the answer. Number of zeros in 443 factorial. Number of zeros in 443 factorial. Let's see who's giving the answer. I was telling about the digit sum also, na? Digit sum with the question I will be showing it, hai na? Or you want me to show it today itself or in the next class? Tell me. Because I was moved. It's more than 1 hour. I just didn't saw. Because number system is a very beautiful concept. Without digit sum, you won't be able to do the questions very easily. Digit sum will take 1/10 the time in any calculation rather than the solving traditional method. How many number of zeros in 443 factorial is possible? 443, divide this by 5. 5 times of 8 is 40. 5 times of 8 is 40. 43. 5 times of 8 is 40. Again, 5 times of 8 is 40. 43. 18. 5 times of what? 5 times of 17 is 85. 17 times. 5 times of what? 5 times of 3 is 15. Not possible now to divide further on. Eliminate this and add all the number. 88 plus 17 plus 3. So this is 10 plus 8, 18 carry 1. 108. So 5 raised to the power 108. Hence we can just say 108 zeros are possible. 108 zeros are possible. 106. Kshitij, are you missing something or am I missing something? 5 times of 8 is 40. 43. 5 times of 8. Okay. 5 times 17, 85. 5 times of 3. That mine is absolutely correct. Check your answer, bacha. No, you should not be taking 433. Clear? So this was your number system, and let me show you the concept of digit sum. Let me give you the example of digit sum. Remainder is this, bacha. Remainder is this. See, remainder is this. Remainder theorem is, see, if 5 is divided by 7, what is the remainder? The remainder will be either 5 or -2. The remainder is positive as well as negative. We were not told about the negative remainder in our childhood. Remainder is extra or the deficit. है ना? 19 divided by 23, what is the remainder? The remainder will be either 19 or -4. So in this particular question, the question is 67 to the power 67 plus 67 when divided by 68, what will be the remainder? See, 67 when divided by 68 will be 67, that I know. But this power is not possible to do. We can't do power of 67 of any number rather than 1 or -1. Power of 1, any power of 1 is possible. Power of 2 also not possible. 2 to the power 67 is impossible to calculate. So what we can do is, let's check out the remainder. When this 67 is divided by 68, when this 67 is divided by 68, the remainder will be either 67 or -1, both. है ना? I won't be taking 67, so I am taking -1. -1 to the power 67 plus of 67 by 68. So this is equals to what? Negative to the power odd number minus to the power odd number will be negative in result. So -1 plus 67. So we have successfully eliminated the power. So this is 66 by 68. And if 66 is divided by 68, the remainder will be 66. Why? Because the smaller number won't be able to divide. See, will you be able to divide? Suppose there is a number and you are dividing by 11. Fine. And if it's 7, will you be able to divide this 7? No. If it's not divisible, if it's a smaller number, that itself is the remainder. So when a smaller number is divided by a larger number, the smaller number itself is the remainder. Clear? So that itself is the remainder. So this is the remainder theorem. So this is a complete. The concept of digit sum. The concept of digit sum I will be taking tomorrow with the class itself. Fine. So remind me, है ना? So that I will be taking. That remainder is not necessary. That is not needed. That is not needed. है ना? In that previous question, that is not needed. You are saying about this, na? So 5 times of 88, what about the remainder? No, that is not needed. है ना? Only we have to take out the quotient. Clear, Apurv? We have to take out the quotient. So I hope this is feasible. We'll be doing each and every topic with the help of Vedic maths. Digit sum is the very important role, plays a very important role in Vedic maths. Clear? So we'll be doing each and every questions. We'll be trying to do each and every calculative question via Vedic maths. Fine. So in the next class, we'll be doing this. So this was our lecture. So myself, Roshan Pratap Singh, all the way from Dehradun. Meet you in the next session. Till then, Jai Hind, Jai Bharat. I hope all the concepts were clear. So do read the session also if it's possible. All the best, officers. Jai Hind.